Hello, I'm Bob Watchorn, and this webinar is on the worldwide structural geology framework of North America. I've been using my own enhancement of data, and the data that I've used is Landsat gravity seismic tomography plans and sections. And over the last 8 years, a lot of new concept has arisen from this research. I might add that at the moment, I think I'm the only person that can enhance this data. And I'll be very pleased if people can put me wrong on that one. Some of the concepts is that the Earth started cooler and gradually heated up, instead of, as at the moment, it started hot and is cooling down. Remember, all the original constituents in outer space that came together as dust were at minus 100 degrees centigrade. Another concept is the Earth started rigid and only started breaking up perhaps in the Proterozoic, and that true plate tectonics commenced only relatively recently, not way back at 4.5 billion years ago. With all my work around Australia, China, Africa, South America and now North America, I've found no evidence whatsoever of lava lamp plumes. And from what I can see is that the lithosphere is generally in situ replaced by heat, which gives the appearance in tomography of a plume. Mineralising fluids from the core scavenge and deposit minerals when they're ascending. So I'll be going through those as we go through the talk. Just briefly, I started in Australia 20-30 years ago, looking in the Yilgarn here. Then gave a talk on Africa a year or so back, another one on Brazil last year, and this one's on North America. The next one will be going and just about completing the circle and doing Russia and China. The geology of North America, always start with what I should know best. This is just really a cartoon of the geology, and it shows the geochronology, and you can't really dispute that, and I'm not disputing that. The fact that the geochronology goes from 3.5 billion years, 4 billion years up in Greenland and Canada, and down to 400 or 500 million years here, and right down to 10 million years over here. And that the continent started as a little seed continent here somewhere and is moving east and gradually accreting, like ruckling up of a rug, all these younger sediments. And the other thing is that the western side's getting pushed by the Pacific plate. And the thing that I find after my studies is I can't come to grips with is that it's supposedly underlain by a mobile mantle, which has been replacing the bottom of the original lithosphere. I find no evidence of that. The mines in North America, there's very poor correlation of the mines with the broad scale surface geology. The only really big ones that I could find that correlated was the Butte and Bingham Canyon. The rest of the mines don't. Very difficult to try and locate all the mines on one plan. I think most of the main fields have been plotted. Landsat straight off Google Earth, and I've plotted the mines on that. The big area you can see here with no mines really, because that's deep alluvials, the outwash from the Rockies. Not much structural geology to be seen in the Landsat, and we need to get detail. And I've put this slide up before. So the objectives and method of enhancement of fuzzy images. As I've said many times, I use PowerPoint, probably to a few chuckles. Cheap, absolutely fantastic, better than ER Mapper for actually doing enhancements and things. And I use the same process as you do when you focus a camera or prepare microscope slides or MRI medical scans. You've got to get your focus, your plane of focus down as tight as you can, and then once you're there you increase the definition of structure. And you go from this is your Landsat image, no structures seen. Smallest you can see is 40, 50 K across, like that's 1,000 kilometres there. And you go to this where I can see structures down to 5 to 10 kilometres, and if I then focus in more I can actually get them tighter than that. So what do we see that's different between the Landsat and my one here? First of all, you can, well, unless you're fairly blind, you can see there's an almighty great big ring structure there, which is overlying another one to the north. We'll be looking at these two ring structures right down to the core, nearly 3,000 kilometres below, believe it or not. So if you plot the rings onto that ring structure, that's what you get. If you plot it over the geology, that's what you get. Effectively, they got absolutely nothing to do with the surface geology. How can this be? You would expect the big rings, big rings like that right on the surface, you'd say, well, they're formed by impacts, should be shock structures everywhere, but there's not one to be seen. This is plotting the mines onto that Landsat, and the mines actually correlate quite well with the lighter parts of these rings, with the actual raised concentric areas of the rings. So they don't correspond with what you see in the geology, they don't correspond with what you see in the unenhanced Landsat, but they do correspond with the enhanced Landsat. So where do these structures, and obviously the mines mineralising structures, originate? This is just a blow up just to show the mines actually following around the ring and up and down on the linears. This scale is 200 kilometres, not much use for exploration targeting if you're really trying to find another one of these mines. So the next little section we'll be looking inside that box there at the Butte mine up here, bigger than Kalgoorlie. Bingham Canyon, one of the biggest copper mines in the world and the biggest open pit in the world. Carlin mine and Goldstrike mine. They're the giant mines of really of America. So we're in elephant country here. So this is those mines put straight onto Landsat. You can see little things, maybe that's part of a ring, maybe, you know, you really can't see anything. We need to get detail and find out if, look through the surface and see what's underneath. That's the same plan, enhanced really to find the fracture systems and linears and rings. So the first ring that stood out at me was this one down here. About 200 kilometres in diameter. It's surrounded by another one sitting out here. And then going from light to dark, there's a large semicircle sitting right out there, which actually that is the centre of. And so question is, do these fairly nebulous looking features relate to the mines? Well, not surprising to me because I've looked at so many of them, but they do. The biggest mines have nearly always been on the rings. Well, in fact, they've always been on multiple rings. So Goldstrike, Carlin's just inside it. Best mines are generally just inside the rim, which is the most fractured area. Butte's on the top ring. Bingham Canyon's on this one here. I've only drawn a couple of linears in. Another type of enhancement that I do, which is really to show the ring structures more than the different textured areas. A lot of structural detail. There's a dartboard ring that sits in there, and another one inside, which is this area down here. Often you see these things a lot better when they're small. So where do the mines and what are these rings that you can see? At least I can see. Well, actually, different set of rings from the other ones, and that's not uncommon when you enhance things. Enhance it in different ways, and you see different features. Just like a tree in the morning looks entirely different, and you see different shapes than the same tree at lunchtime. So the mines, once again, the big mines are sitting on multiple rings. And also the Bingham Canyon and Butte mines are actually sitting on geological boundaries of huge age differences. Up in here it's 2.5 billion years, just over here it's 3.5 billion years, down here it's Proterozoic 1.5 to 2. In here it's Ordovician, right down to 50 million years in the Cordillera. So how come you've got all these young mines, 50 million years, 38 million years, right down to 10 million years out here? How come they're sitting in these really old rocks? Generally in Australia, they're not a great deal of difference between the age of the mines and the rocks. Maybe 50, 100 million years, if that. I think just the comment is that the rings are the source of intrusions and magma coming up right through the whole geological period. And it just so happened that at this particular point they've actually been mineralised. Now I'm going to use gravity. This is a potato Earth, which effectively is the red is the heaviest gravity, so you put a big bulge on it, and the blue is light, so it forms a valley. One thing that's very interesting, well actually the Hawaiian hotspot took my eye first. I said, well, if it shows the Hawaiian hotspot, which is pretty small, we should see structure in here once it's enhanced. So the Earth, like if the Earth had a mobile mantle, this is my first dig at a mobile mantle, for this session anyway. If the Earth had a mobile mantle, there's no way that the Earth would be so out of shape as that, because the mobile mantle is by definition mobile, and it's equilibrating all the time, and the crust only varies from very small amount. If it was to do with the crust should actually, the Earth should be thick here and thin here, but it doesn't. It goes right around. Of Earth girdling structures. So this is just looking at North America in that data. It's no use whatsoever looking at it to try and define structures, except the geography. You can see by the geography that there's obviously a big structure running down there with all the Bear Lake, Great Slave Lake and all those going down to the Florida, and then the big embayments in South America. That caught my eye, and also the fact that the diamond mines line right up along that. So I'm calling that the diamond mine, and we'll actually focus on that quite a bit during the talk. So when you enhance the North American gravity, hopefully you can see rings, a ring there, a bigger ring that runs right around from the top around here, sort of a semicircle. The one that's most easily seen is the one just off the coast on the eastern side of America. There's another one sitting there, other ones all over the place. And once again, like all the other places I've seen, this is to scale, so they're the same scale. They're the mares on the moon. So the mares formed, the last mares formed 4.1 to 3.8 billion years ago. Obviously there was heaps and heaps of them before that, because when I enhance the moon I can see all these other ones that sit in behind. But the last ones formed then, and then the lavas that came up, they finished about 3.6 billion years ago. There's been almost no big impact since then. In fact, there has been none that would form this. And the moon is a pretty big place, and if the moon hasn't been hit by any of these, then you can absolutely guarantee that Earth hasn't been hit by them either. So these impacts are pre 3.8 billion years old. However, the surface geology, as I said, is much, much younger. That's just the rings drawn on. The way that and you can see it on the moon, is that the crater centre fills up with thick lava, and the only place that anything coming up from below can get through is on the rim or in the centre of the crater. Therefore you get different heavier rocks, in this case, coming through and forming a circular pattern, which is a palimpsest of the rings that are down below. This is the same plan with the rings shown and the mine shown. Once again, you can see the diamond line through there. You can actually see very plainly very strong linears there, and in this direction you can see this ring has got the diamonds around the bottom end of it. This one hasn't got any because it's out in the Atlantic Ocean. So can we use these rings and structure and the method of actually getting the structure for exploration targeting? So I'll quickly go through the mines. So the gold mines appear to be associated with the rim here and the rim of this ring. I've only plotted very few of the gold mines. However, this is the Abitibi belt and this is the big California belt, so the best ones form on the rings. There's a few follow the linears, but they correlate strongly, but not absolutely totally convincingly. The iron mines, I think in the US, the best iron mines are actually around the Lake Superior area. Lake Superior sits right under that. And they're also around this small area here. So the actual iron mines in the US are really mainly associated with one ring, and that's the strongest one that's on land. In Western Australia, the 95% of our iron mines are up in the Pilbara, and 95% of those are actually in one big ring structure about 500 kilometres across. So absolutely the same as in the US. They've so is the iron there because the meteorite that came down was an iron-rich meteorite, and the iron's been picked up by the fluids coming up from below and staying within the ring, or has it a deeper source? I mean, there's nothing got more iron in it on Earth than the iron ore, iron core. So did this iron come right up from the core? Nickel mines, they not a very convincing pattern, except that there's quite a few struggle around the edge of the large ring there, and quite a few in the intersection there. We'll look at nickel a bit later. Just out of interest, how far would a 2,000, 3,000, 4,000 kilometre diameter impact actually penetrate into the Earth? Well, if it went down as a hemisphere, it would penetrate whatever its width is. So a 4,000 kilometre impact would go down 4,000 kilometres, which is ample to get down the 3,000 to the iron core. Diamonds, I like diamonds because they seem to be very structurally oriented and they seem to behave themselves. So here, the diamond line, interestingly, in the northern hemisphere, it's sinistral movement. Southern hemisphere's dextral movement. Here you can see the sinistral offset on the diamond line. And the actual mines are associated very strongly with the rings, inside the rings, outside the rings, and also very strongly on the intersection of that line with the ring structures. Everywhere I've seen, the diamonds have been associated with smaller rings, and no different here. Uranium. Now, if there's one mineral that can't occur naturally on the Earth, because Earth only, with its heat in the centre, still can only produce things like iron. It can't produce any heavier elements. So where did this uranium come from? It's strongly associated with a weak ring here, and in Western Australia, about 90% of the uranium in the Yilgarn anyway actually is all in one ring. It's just like the iron ore. The ring, Barrambie ring, actually contains pretty much all the uranium and vanadium. I'm not sure whether they're related or not. Also, the uranium occurs here where you've got very strong linear structures crossing that ring. We'll come to seismic tomography now. So that was just plain old gravity, which normally most people will pass off as useless data unless you've got microgravity, but I'll tell you what, you can see lots and lots of data in very broad scale gravity, and you don't get any broader than the potato Earth. So once again, these images I'm using, which are only going to use two of them, the 60 kilometre and 300 kilometre depth, they're not particularly smart to try and to think you're going to get too much detail out of. This is a attempt from about 3-4 years ago to have a look at it, and I could see rings back there if I took my glasses off and fuzzed my eyes. So I actually named them and wondered, well, in the future I might have a look at these later. One thing for sure is that they didn't correlate with the geology whatsoever on the surface of North America. I've named the rings pretty much after the states. So it's the same data, almost unenhanced, and immediately this almighty great big ring pops out. All I did was a wet look and there it was. So the big ring we were just looking at in the gravity is the black one there, almost identical to this one here, except the Manitoba ring is 1,000 k north of the other one. The Moho's in between, that's interesting. What it means I'm not sure. Are they the same rings that have been shifted? If they are, none of these other rings have been shifted either. I didn't really have much of a go at enhancing this data. I just enhanced it enough to see the smaller rings within the larger ring, so I could see how the mines associated with them. We'll just briefly look at the nickel mine. When in the South American talk I gave, I made note of these huge, big west-northwest structures right across the whole Earth. Continents and everything follow these west-northwest structures. And not only the continents do, but the nickel mines do. So I should imagine if you look in that direction, well, nickel in Australia, Africa and North America, particularly up here, Boise Bay and those. If you look right along that line, which I might do one day, and just to see if there's nickel mines right through. Just a plug for my old mate Tim O'Driscoll from 40-something years ago. He showed these to me as his Tethan twists and garnered very much abuse, I think, over the years, because he actually was the first to see these things. Now that you can actually see them, you can all apologise to him. So we go, just looked at the uranium mine, and the uranium mine's obviously still in the same spot on the surface, and they're still associated with 2 rings in the west coast here. If you look closer on this one, you can see the rings very clearly, slightly misshapen there. But they're the biggest mines, and they're associated with the biggest ring sitting in this area of the world. The diamond mines, leaving this last because it leads on to the next section. So this is a enhancement that I do to try and pick out the late brittle structures. Not only does it pick out the late brittle structures, but it actually picks out the really the morphology of the actual whole area, and the morphology at 60 kilometres depth is brittle. In fact, I was looking at my coffee table a few days back and said, oh, I'll tell you what, these structures here remind me exactly of my coffee table, which is a limestone that's been broken up and then indurated with calcium carbonate. I think that's actually exactly what the whole of the Earth at probably 60 kilometres depth has happened. Been broken up, not shifted around necessarily a great deal, because otherwise the rings wouldn't be still circular, and then annealed. So hopefully you can see these large linear structures, and the fact that the mines follow them means that the mines are coming up them. We'll have a quick look at the Abitibi area, which I did some work on about 6-7 years ago, and a little bit more recent in the second slide. Huge mineral production area. Gold, copper, nickel, silver, lead, zinc. About 6-7 years ago I noticed with my penchant for seeing rings and everything, that there seemed to be rings in and around the Abitibi area. So I got some data and tomography data at 100 kilometres depth, and had a look, and sure enough there was a ring right next to Abitibi and another little one off to the side. This is just an enlarged area of it. A lot easier to see on the smaller area. So the actual mines run east-west there. So I had a bit of fun to actually see if I could hone in on the actual structures of the Abitibi area, because it would be very interesting to find another Abitibi area either to the west, east or whatever. So I wanted to see if there was other similar structures. So that's the slide from 6-7 years ago. I wormed, flattened and structurally enhanced that data, and the actual ring came out better. So the third slide here is has been wormed, and I wanted to see if the mines, like they did in Africa and South America, actually sat on the worms, which they sort of do, but not very convincingly. So in this slide I wanted to these two slides, I wanted to try and hone in on the actual structures. So after a lot of fiddling around, and I actually ended up with the structures at 100 kilometres depth coming out quite clearly. And at that depth, they're still, they're actually right under, they're as underneath the mines at that depth as they are in the little section down here, which is actually where the mines sit, and that's at the same scale. So in terms of exploration targeting, I would be looking along here, down there, up in that direction, and up in that direction, and down there around that ring for extra extensions to the Abitibi belt. 300 kilometre depth, there's almost no correlation with the unenhanced data. When you enhance it, it seems at the moment down at this depth we're getting into brittle territory again. Quite brecciated at this level. There's rings that appear. Once again, it's actually the Lake Superior ring, which we saw right up near the surface. There's other rings that you can see. I'll toggle backwards and forwards. That's how I've interpreted them. And that's why I interpreted them, because they really are quite plain. Very dark boundaries between these other domains, which all seem to be broken up, and a lot of very fine detail in each one. So the outside edge of this ring structure, which appears to be broken up a little bit by the Pacific plate coming through, that's 4,000 K up there. So if it is actually the same ring, even if that is, then this ring's 8,000 K diameter. And that's the same as the largest ones that we've seen in the previous webinars in South America and Africa. The mines, well, once again, we've got our Nevada ring over here with the mines in it. There's a good correlation between the diamonds and inside this ring and the diamonds on the bottom half of that ring, which is actually where these rings actually impact on the diamond line. Going to have a look at the inside this area here, which surprise, surprise, the Bingham Canyon Carlin mine area again, focusing on that because it really is the standout area in the US for big mines. If we can crack why they're there, then maybe we'll have a chance of cracking the smaller ones. This is tomography plan at 300 kilometres depth from 2013, 8 years ago. If there's been any advance on that detail, I'm sure there has. However, none of it's on the public internet, which is a bit of a shame for people like me. This is a poor plan for detailed exploration targeting. So we've come into that area now. At this scale, you can see well, runs in the same direction as the diamond line, but it's a long way to the west. You've got other linear structures in this direction. You've got east-west ones. Lo and behold, the big mines are all in amongst where you've got the east-west ones and the northeast and northwest ones. And we're now looking inside the yellow box that was on that previous slide, so we're coming right down into the Carlin Bingham Canyon area. Now on this one, the first thing that when I enhanced this one was this ring structure here, and this little ring structure here, another ring structure sitting inside it. You can see it better down in the when it's been reduced. How do these relate to the mines? The other thing is that there's, if this was a microscope slide or you're looking at an underground opening, you would map these structures here as crenulation structures. In other words, brittle structures that have been bent. And in this case, they're sinistrally bent again. flat S structures. Once again, unsurprisingly, the mines actually, the big mines sit in and around the actual rings and on the major linears. So Gold Strike's just outside that one, Carlin's right on this major ring, which is this one here, and Bingham Canyon's just inside this one. So then worming being one of my favourite pastimes, you can actually see heaps and heaps and heaps by doing worming and then enhancing it, lightening it or darkening it or giving it greater contrast. So in this case I darkened it and then gave it contrast until the strongest crenulations appeared. And in this case the strongest crenulations, not necessarily there, but a lot of the mines sit on the strongest crenulations. Almost none of them sit in these dark areas. So that's a good targeting criteria. Right there I could pick many lines that cross the rings that I would target straight away for other mines there. Now we go down to 550 kilometres depth. It's the deepest seismic tomography data on North America I could find. The mines absolutely show no correlation with the tomography at this depth. However, what will the detailed tomography reveal? Remember, we're way down into the mobile mantle at the moment. Well, doesn't look very mobile to me anyway. Once again, it definitely is more, everything's a little bit more strung out, but you've got these huge big structures still just trundling right from the Pacific plate right across America, right up following the peninsulas up into Greenland. You've got other ones. This is the Tethyan twists, so to speak, that go from Australia right through to North America, linears. And also you've got ring structures. The ring structures actually show up better in a less enhanced slide and a smaller one. There's multiple overlapping rings. What I want to do here is these are the strongly deformed areas. So black is strong shearing, well, whatever shearing looks like down at 500, but basically non-reflecting seismic data. So do the mines preferentially sit in these really strongly deformed areas? Because if they do and you can find another strongly deformed area out here, you're on your way to hopefully finding more mines. Well, the actual mines, unsurprisingly, do fall in the strongly deformed areas. That was the deformed area there, and the more deformed areas in the centre. You can actually see the mines actually following right around this ring here. Remember, that ring is 550 kilometres down, long way down. Not only is the other mines following this ring down here, but they're also the Northwest Territories ring, the diamond mines in particular, and the gold mines sort of actually follow around the inside of this highly deformed area, which is an ovoid shape. Perhaps it's an ovoid shape because because of the projection of the plan. You can actually see there's almost no mines down in this lighter coloured area, but when you go around the outside edge, you've got a lot of mines. So the idea would be to try and find more of those highly deformed areas as a targeting tool. Just a quick one to show the large ring, which took me quite a while to define, so I'm not going to ask you to actually believe it at the moment, but it is there. So continent-wide exploration targeting. Now we're starting to talk business. Well, we're talking business on the large side. We had a look at the Carlin area getting down to sort of 50, 60 kilometres where we can target very carefully over in this area. Now we're looking for, 3,000 or 4,000 kilometres area. So all I did here was actually look at the where the rings intersected and put a target on them. And I relatively studiously avoided where I knew there were mines anyway. So I haven't actually drawn them on there, but if you look at, they're actually very good target areas. And I thought, well, maybe this is a bit useless anyway because there's no mines there, because this is the huge big Mississippi Valley and the outwash from the Rockies all through there. So what are you going to find there? Well, actually you can find good for gas and petroleum and oil shales and all that sort of stuff. So these really would be targets for those type of commodities rather than the metals. So back to diamonds. So we've already seen this plan effectively earlier on, how the diamonds follow this orthogonal shearing pattern and also sit on rings. This is the new data from the 550 kilometre level. Absolutely the same system as what you got further up. Same ring even, Lake Superior ring. However, I sort of thought back and thought, oh, I've seen this somewhere before, and this is where I've seen it before. In Africa, exactly the same pattern, and a line running down through there. Very strong line. There it is there, I didn't draw it on it. And in South America, these diamonds here at about the 60 kilometre level, they're fabulously strong structures, and you can still see them way down at 500. Oh no, what's that one? That one's at about 170 kilometres, I think. So how can you get, if you've got a mobile mantle and continents have been going around all over the place around the Earth, how can you get exactly the same structures all over the western and far western hemisphere of Asia and Africa? How can you, half the world effectively, how can you get the same structures and the diamonds following exactly the same pattern on them? They should be really at random, because the diamonds range from 2 billion years old right down to sort of 50 million years old. Shouldn't be on those same structures. So I went back to the tomography at 200 kilometre depth that I did in the South American talk. On this one there you could see rings. This is the original data. And you could see rings there all the way running down, big rings, little rings, and you can also see this huge, great big linear structure. You can see the linear structures that we could see in North America actually go right down to, pretty much down to Australia, Fiji, cut straight across at 200 kilometres depth, the mobile mantle. This is what I call the 4 billion year old immovable barrier. And if you look on this, there's also other big arcs that run around the Earth here. We'll see how the diamonds relate to them. So in actual fact, you can see the diamonds in North America inside this ring and around that ring. Africa, they're around that ring. South America, they're around that ring. They also line up beautifully along the almost, big linears that run right around the Earth that are roughly normal to the axis of the Earth. So if you look at Mars, you look at most other planets, you will see these big rings that run around horizontally. Now they're all rigid. They've been rigid planets probably ever. And that's another reason for me thinking that Earth has been rigid for its whole section. So normally you find them here and you find them up there on, I think it's Mercury and Mars. The diamonds absolutely definitely follow them. They also sit either side of these big structures. To me that's very interesting. It's starting to get a framework of the, this is looking at each continent, and this is building the house from the continent. I don't think most geoscience has got much past this stage at the moment. Even, most of them haven't even got to the stage of defining the framework for a continent, not that I've seen anyway. So how does these relate to the continents and structures? So they're the rings and the features that I pointed out. That's the continents. So I did another targeting exercise here. If I had a few $1 billion, if I was Elon Musk or one of those people and wanted to spend a few $1 billion, this is probably where, and I was looking for diamonds, these are the spots I'd be looking. So on the, where the biggest diamond mines are, and on the intersecting linear features that they sit on. Because they're actually relatively late, I think the linear features probably got a lot more to do with where they're located than the rings, even though they are on the edges of the rings. Then I went one further and looked at the metals occurrence with the structural geology at 200 kilometres depth. And unsurprisingly, they also fall on the rings and on the long linears. China, which I did quite an exhaustive study on, there's a large ring there, but China actually sits on, this ring actually sits on a larger ring. Africa, all the mines sit around these rings. South America, same thing. So this slide shows the rings and the associated mines off the previous slide. Can see the, Finland that I did the work on, some work on, the best mines sit right around that ring. China, I did a lot of work on that area, and there's a big 500 kilometre ring where that black spot is, but the whole lot of that hugely rich field in China actually sits on this major ring. So why wouldn't you be ducking all the way around those rings, you Chinese people and Russians up here? You can also see in Africa following that ring, South America, you could see this one better previously, following the rings. In Australia we know that they follow the rings, but this scale is pretty hard, apart from across through there. The central Australia is right on a large ring. So summarising the rings, I guess, at the various depths. So North America here, Africa, South America, Finland. These are the rings in North America, that they're the rings that I've found. And this one is exactly the same as one of these large ones on the 200 kilometres. So that's 500, 175, 400 kilometres depth, 250 kilometres. The background's 200. This large ring in South America is roughly the same size as the big one in Africa, and the biggest one's here. And I'm not saying that there's not bigger ones than that kicking around, because I see these huge arcs, but I don't know what they apply to. One thing that verifies the data, I guess, is that this ring up in Finland, well, that's the Caspian Sea, and that's Finland up that end. It corresponds exactly with where it should sit. All those little rings that are sitting there, they actually, like the ones on the moon, they sit right around the rim of the big ring. Another thing that verifies the data to a degree is this ring here. You can be seen in this data, the background data, and in this corner of this data. I guess the main point to be made is that I might seem to be harping on it, but these rings should not exist in a mobile mantle. Now we've got a good cross-section of depths there. They absolutely should not be. They should all be out of shape and strung all over the Earth. Looking at a isometric section and plan at the 550 kilometre depth. And this one's mainly to tie in the core, the 5,000 degree core going down to nothing, basically degrees on the surface, big temperature gradient, and there's very strong pathways up through here, which is where I believe the mines came from. You could actually see the mines relating to these pathways in all the places I've looked at. The other thing is that, that the 550 kilometre level, which is this one here, in and around the 450, 650 discontinuity, there's this big down warped bowl, I would guess, and it's exactly where the Nevada ring sits at 550. So if that was down there, that's a big bowl structure. This is the new part, I guess, an extension of what I've spoken about before, trying to track the source fluids down further by superimposing the mines on structures and things down on the core. Stands to reason to me that the big heat source is the core. The fluids aren't going to suddenly arise from halfway up the supposed mantle or halfway up the lithosphere. They're going to arise right from the core. So if they do arrive right from the core and they're really hot, they're going to ascend vertically. They're not going to head off at weird angles. So the mine should sit right above where the hottest spots are on the core. So do these spots on the core relate to any rings and linears like they do? So that's a ring on the core, another ring's on the core, huge ring over here on the core, and linears on the core. That's the original data. Couldn't get too much out of that if you tried. So the spot on the core under North America, that's North America there. That's the rings on the core, and once again the mines straddle this ring here. They also straddle these rings here. Diamond mines in particular are associated with rings on the core, which confirms my belief effectively in the plumbing system of worldwide mineralisation. I do believe that the fluids at least have come from the core, and I'd say a lot of the metals have as well. So as the fluid travels up, it'll ascend vertically, but it'll also, pH conditions will mean it'll deposit and scavenge metals all the way up. So I'll bet you if you could take out a big section of Earth all the way to the core, you would find mines the whole way. This is just a summary, I guess, of what I've just said. You can read that. This is a summary of all the ring structures as you look from the moon. Don't know how that got there. From Carlin is the actual centre point of that arrow. So they're all aligned and they're all spatially in the right spot. So the only reason you're seeing all these rings here is the fact that that's the only area I've looked. If I looked out here, I'm sure I would find just as many rings as I could see on the worldwide. a tomography at 200 kilometres depth. This is just to show you how this data actually correlates with what we actually know about the Earth, and also totally refutes what people think they know about some parts of the Earth. So this is the upper lithosphere. This is Africa coming across. You see the big pushing structure of Africa there, collision structure lifting up the southern edge of Europe and the Alps. You can see the, well, there's a sort of a fracture that ends up at Iceland, but we don't see any amorphous looking plume sitting up there. There's structures and fractures and things running right through where the mid-Atlantic ridge and the Icelandic plume should be. The only things that look like mantle are these slightly fuzzy looking areas, and I'm sure they're partially melted areas, and they appear to be feeding the Iceland hotspot. Have seen a plan with a big circular diagram where it comes up, goes around and back down. Well, the Earth as a whole doesn't come up and go back down, but the heat may do. Over here we've got the Glenville line, pushing structure. You can see that pushing up the east coast of America there. And you can also see a lot of the bowl-shaped structures as you go across the continents. And the lithosphere is absolutely totally continuous all the way. The surface lithosphere is continuous all the way from Saudi Arabia to the Mexican border in America, which on most plans it definitely doesn't show. This is the second last slide. I thought I'd try and summarise things. That so a year or so ago we did the African one where we got all the sections through Africa, and they corresponded with the geology very well, the African rift. And the big surprise there was that these rift structures and things went right down to the core. Didn't believe it at the time. Thought, well, I'll have a look at South America, see if the same thing happens there. Same thing happens there. And in that I found that there was no evidence of a huge big amorphous zone in the middle of the Atlantic that should correspond with the mid-Atlantic ridge. All I found was a little thin, about 150 to 300 kilometre wide amorphous zone running up there. Continuous lithosphere all the way up here, and on the other side, or the Pacific side, it appears a lot more convoluted. That's why what I called the immovable barrier that's been there for 4 billion years. This is what we've seen in North America, almost exactly the same as South America. Continuous lithosphere with big structures, big flat structures going right through the whole, down to the core. America is just getting pushed like this, 110 millimetres a year from the Pacific, and 60 millimetres a year from the Atlantic side, and it's just getting crunched, getting lifted, as is South America, and perfect for pop-up structures and extension structures for mineralisation. So the discoveries, late heavy bombardment ring structures up to 8,000 kilometres diameter, go right down to the core. Brittle structures and rings to the core with sinistral movement on all continents. That absolutely wouldn't happen if the continents or parts thereof were moving all over the Earth. You would get movement all around the clock. No evidence I can see whatsoever of a worldwide mobile mantle. I'll be very happy if somebody can provide it. Evidence that the seafloor, Atlantic seafloor spreading is relatively narrow and about at 50 degrees, 60 degrees east dipping. The evidence of the 4 billion year old immovable barrier from Alaska to Terra del Fuego. And we've made a start, I guess, on targeting diamond and metal mines using structural geology over the whole world. New paradigms that I think we might need to get our head around in the next few years is that the Earth started cooler and gradually heated up. I'd like to see the physics for it starting very hot when all the original constituents are at minus 100. Earth started rigid and only started breaking up perhaps in the Proterozoic. Back to that original constituents at minus 100. If the Earth was formed about 4.6 billion years ago, by 4.4 billion years ago, it still had water on the surface. It had water on the surface and everything was rigid, so it seemed to me that it's started rigid and only started breaking up in the Proterozoic. Plate tectonics commenced relatively recently. No evidence whatsoever of lava plumes, and the lithosphere is in situ replaced. We've seen planar and ring structures right down to the core, and they correspond and correlate very well with the surface mines. We've the concept of sending mineralised fluids from the core, scavenging and depositing minerals along its path right to the surface. I'd be very happy to have questions on that, finishing on that topic. So thank you very much.